Hi everyone, welcome to another tutorial. Today we're going to be learning how to make this system in which, as you can see, a texture gets stretched to fill the spaces determined by a different silhouette from any given input that you want. For this, we're going to create this glsl shader that, if you've never done or used shaders before, it may be very interesting to see how you make this, and then from that information that we get with a shader, we can use that to generate a UV map and generate our texture like this. I'm gonna start by deleting everything, and we have here just a constant with 4 parameters, which is our resolution that we're gonna be working at, and a grid resolution, which this system works with an underlying grid, and we are gonna see in a second how that grid affects the final output. But I'm gonna start with just creating the input, which can be anything you want. In this case, I'm gonna just use the banana, and let's fit that with the resolution that we're gonna be working at. And I can add a transform to have it be rotating so we can see the grid changing. I use uptime frame, and this can go into a null. Then we can call input, so this can be whatever we want. And from that, we have to generate a mask, which is basically just when the mask is on, is 1, we don't try to fill that space with our shapes, but we leave that empty. Let's use just threshold, and I can threshold the alpha, and that's our mask. And now let's fit that into the resolution of our grid. So let's put that here with grid, and let's turn this into nearest and nearest. And it's very important here that we use fill, because we have to use the same information without creating empty spaces. And you can see if I stretch this texture, this is getting stretched as well. So we can keep that at 80 for now. And let's call this mask. That's our mask, and then we can use our glsl top, and we're gonna do a compute shader, so we have to change this to compute shader. We can delete this one, and on this arrow over here is our compute shader. And now, how is this going to work? We're going to be working with a grid of points, of pixels, and that have a corresponding mask. Each pixel, each point, is going to traverse horizontally to find where is the nearest mask. So basically, it's going to launch an arrow in a direction until it reaches either the edge of the texture or the mask that we have given it, and it's going to do the same thing in the opposite direction. That is going to give us 2 coordinates, a low and a high horizontal, that represent the collisions basically that pixel sees on each side. And then we can also traverse our texture, but now vertically, and instead of going until we find a mask, we keep going as long as the coordinates of our horizontal collisions are the same as the point we're currently evaluating. So basically, if the points vertically that you are looking at have the same horizontal collisions, that means that it belongs to the same rectangular area as you, and that's evaluated for each pixel. And once we have those minimum and maximum both in horizontal and vertical, we can use that to rearrange our current position for each pixel into 0 and 1 locally for each area. And now that we have this grid with that information, we can also turn this into a higher resolution, to our final resolution, and make it so that it's a UV map that is stretched for each different area. that is all calculated based on a dynamic mask. So in order to do that, on this glsl, we are gonna run two different passes. So over here in the common tab, there's these passes, a parameter, so we can add that to 2, and basically this changes the amount of times that this shader gets evaluated on our top over here. So basically a second pass receives the output of the first pass and then does this operation again, but we can run a condition over here so that each time on each pass we have a different thing, a different operation. So on the first pass is going to be our horizontal traversals to get the horizontal collisions, basically. And on the second pass, we can get that information from the previous pass and then run our vertical traversals to find the whole area and then output our final information. So let me go into this compute shader and edit. So basically this is our default code, and we'll delete everything. I'm gonna leave this over here, and this is going to be basically function as our default output. So basically by default, if nothing happens, we want to output just 0 on all channels. So this basically just gives you an empty pixel. And now we can run a conditional for depending on which pass we're on. Now TouchDesigner provides for us a uniform called UTD pass that tells us which pass we're on. I recommend a lot for you to check out the article on the TouchDesigner documentation called How to Write a GLSL Top, which you can see there's a lot of useful functions and uniforms that TouchDesigner provides for us to use within these shaders. So this is basically just a counter that tells us what pass we're on. It starts at 0, so on the first pass is 0, and the second pass is 1, and so on, but we are gonna only have 2. So basically, we're gonna have a section of the code that only executes when we are on the first pass, and another one I'm gonna just have an else, and in this case it just will be on the second pass because we're gonna have only 2 passes. And inside of here I'm gonna have also some exit conditions, but in case they don't we don't reach them ever, we have this kind of default output, because you should always have a defined app. That's a good practice, I guess. So now this is within our first pass. We can get first our mask, the current pixel information, if it's on or off. I'm gonna get that as a float with a texel fetch from our first input, which is from this sampler, which is from our 2D inputs. And the first one, which we only have one, and we have to give it an 2D vector, which is just going to be the one we're currently evaluating, and then a 0 just to fill out the needed parameters. And in this case, we can just look at the first channel, assuming that first channel is representing our mask. With that, we're gonna start our traversal. We have to create a counter that moves in one direction until it reaches the edge or it reaches a mask that is on, and another counter that goes lower and lower until it reaches the other end of the texture, or again it reaches a mask that is on. So we have 2 different counters. So I'm gonna create this. It's gonna be horizontal high, that is going to start at the place we're currently evaluating, global evaluation ID on the X, so the horizontal value, plus 1. So we start already stepping to the right, and another int, which is the horizontal low, and this is basically the same, but at -1. And now, first, I'm gonna create a conditional, because we only want to do this whole traversal if our mask is empty, if this value is 0, because this part where it's filled is basically where we want to not stretch our texture or do anything but leave empty. So at the end we can comp our initial input over that. So first I'm gonna say if the mask is not 1, only if that's true we're gonna do all of this part of the code, and then I'm gonna create a while loop that's gonna repeat increasing our counter until it reaches one of the conditions that we want to reach. So while our horizontal high is less than the horizontal resolution of our texture, which we can get from this uniform. So it's from the 2D inputs, we get the informations, and we get from the first one, which again, we only have one. And in there's a resolution component, and the horizontal resolution is on the third channel, which is Z. And while that is true, we're gonna keep adding to that counter, and we're gonna keep sampling from the texture to see if we already arrived at a point where the mask is on. Let's get a float sample, and again with a texel fetch, and this is the same from the same input, the first input. We only have one, and we have to send to the vector, and in this case we have horizontal is our current counter that we have reached, and vertical is just the vertical position that from the correct pixel, right? And then a 0, and again I'm just gonna use the first channel because that's enough to give me the mask. And now if our sample is equal to 1, which means we reached a point where the mask is solid, where the mask is on, we can break out of this while loop. So that will mean that this high counter will have reached the maximum point at which you are within the mask. So that you should stop right there, and that break gets out of that while loop. Now this is our traversal towards the positive side, and we're gonna do the same thing to the other side, so to the negative. So I can copy and paste this, and instead of using this h high, I'm gonna use h low. So I can copy and paste it over here, and here this conditional, instead of going until while it's less than the resolution of the texture, so while it's within the texture, we have to do it on the opposite side. So instead of less than the maximum, I go more or equal, greater or equal than 0, which is our minimum. And it's very, very, very important here that it's minus minus. If I were to forget to change that, then this loop will go on forever, because they will be going up, so this condition will always be true. So it's very important to change that over there. But this is basically doing the same, but in the opposite direction. So this is going towards the left one at a time until it gets to the edge of the texture or finds solid pixel, basically. And now for the way we're gonna later rearrange these values for our final UV, we're gonna add here another another 1 to our horizontal low collision, and just for ease of operation later. That's it basically for our traversal, and then that's what we do on our first pass. And that information that we got from the horizontal collisions, we can send over to the second pass for it to use. So here, outside of this mask conditional, because even if we are within the mask, we still have to send also the mask information to our second pass. So our second pass knows the original mask. So we can use this same function over here, the image store output on 0, which is we only have one output, and our current position that we're evaluating. And let's get a vec4, which is gonna hold our information, and we're gonna set the horizontal low, the horizontal high, the third one I can leave empty, and I'm gonna also set the mask. Because on our second pass, instead of getting the original information from the actual node that is connected on the TouchDesigner network, we're gonna get the output of the first pass. So we also need to send over that original information, right? And over down here, I can also return, important here to return, so that we don't reach this default output over here that is just empty. We'll see in a second how we're gonna use that, and then that's it for our first pass. Then over here on our else, which we can remember is just if our UTD pass is not 0, then else we can now use that horizontal collision to traverse the texture vertically, but now our counter is going to keep going until it finds some pixel whose horizontal collisions aren't the same as your current pixel that the shader itself is evaluating. So it's gonna keep going as long as it is still within that rectangle that it belongs to. So first, I'm gonna get all of our data that we got as output from the last pass. Call that data, and we can use TouchDesigner fetch, and it's gonna be in as our input, right? So same as before, and again number 2, and like this. And now I'm gonna get the entire 4 channels, and I know the mask is at the last channel. I set it over here, so I can get mask is equal data.alpha, so 4th channel, and I can get the horizontal collisions as a vector, and that's data.xy. And now I can basically do the same thing I did, but instead of doing horizontally, we do it vertically. So again, I'm gonna have 2 counters, a vertical one, which starts at our vertical position +1, and a vertical low, I think I said vertical here, that starts at our vertical position -1. And we can also only perform this traversal if our mask is positive. I mean, if our mask is negative, is off. So if our mask is not 1, then we can do all of this. And now we do again a while loop, and as long as our vertical high is less than our resolution, which is on the infos uniform on the first input res, and it's on the 4th channel W, and as long as that is true, we can keep going. And again, I'm gonna be adding to this counter, and let's get our sample. Now we're gonna sample the first 2 channels, and as you remember, that holds our horizontal collisions that we got from the last pass, and we're gonna compare that to the horizontal collision of this current pixel. So let's do your sample, and another TouchDesigner fetch, and the same sampler, first input, and our vec2 is going to be for the horizontal, just the current horizontal coordinate that we're evaluating, and vertical is our current counter, and 0, and we can get only the first 2 channels. And now our conditional for breaking out of the while loop is if our sample is not the same as our horizontal collisions, then that means we are currently out of our area, of this rectangular area that we belong to. So we can break. So that's good. And now I can just copy and paste this and do the same thing, but with the vertical low. I can paste this over here. Vertical low. And this, instead of going for the upper limit, we'll go to the lower limit, which is more of or equal 0. And here, again, very important, that it's minus. And again, for the rearranging ease later, I'm gonna add just 1 at the end to the lower collision. Okay, that's good. So now we have calculated, we have the horizontal collisions from the last pass, and we have calculated the vertical collisions on this path. So now we have the minimum and maximum bounds of this rectangle of space, and we can use that to rearrange our global position or global coordinates within the texture to the relative positions within those rectangular areas. So let's do that down here. I'm gonna create a vec2 that is just our lower bounds or a lower point in this quad. That is going to be a vec2, and it's going to be the horizontal low, which I have on the horizontal collisions on the first channel, and our vertical low. And I can make a vec2 that is a high, and basically the same, our horizontal collision high, and our vertical collisions high. And now with that we can use a rearranging function, because we know our current coordinates fall within these 2 points, basically these 2 2D points, and we want to rearrange that from within those 2 points to be between 0 and 1 within those 2 points. So let's get a vec2 that I'm gonna call UV, and we can use this other helper function from TouchDesigner that's called TD remap, that basically gets a value and you give it its lower and upper bounds that value kind of ranges in, and you give it new bounds that you want it to now range in. So we give it our coordinate, and we know that it goes from that lower bound to that higher bound, upper bound, and now we want it to go between 0 and 1. So 0 and back to 1. So that's good. And now we have this UV, and we're also gonna need to output the size of the quad that this pixel belongs to. So we can use that with another vec2, and we can just get that by subtracting the higher bound, the upper bound, minus the lower. And this is right now basically in indices, so it's integer values, and we want that to be between 0 and 1. So I'm gonna divide that by the resolution of the whole texture, which again we can get from the infos uniform from res, and it's the last 2 components, so channels, CNW. And now that's basically it. We can now send out this final output with another 3D image store. And on our first output, we only have one. Current coordinates, and let's send our vec4. That's gonna have the UV and the size, and that's nice. And we also want to return over here, so we don't reach this default case where it sends out this default output. And because we did all of this within only on this conditional that the mask is not on, that's going to mean that when the mask is on, when the original mask is 1, this is gonna reach this default output. So the pixels that had the original mask on is gonna be left as empty, which is what we want, because we want only to fill the space around our silhouette. So that's good. We can finally hit save. We have this over here, and now it's important to change this pixel format to RGB. Try to be float or 16-bit, I guess, but make it a float. As you can see, this changes because when we output from the first pass and we give that information to the second pass, it actually ranges far above 0 and 1. So you actually need it to be a float, so that the correct information is sent from one to the other. And I'm gonna set this to nearest so we can see the nice grid. And now we can fit this low resolution texture into our high resolution that we want our final thing to be with a fit. And let's grab these values. And over here again, important to use fill. And you can see, let me set this to nearest, this stretches the pixels back. You can see this looks pixelated, but this is now fits well. The silhouette is the same aspect ratio and everything from the original input, and that it doesn't matter if our resolution that we're working with isn't square or that our grid that we're working with isn't square. And we can get the information because remember, on the first two channels, on red and green, we have the UV, and on the other two channels we have the size. So let's use a reorder. I'm gonna set this to RG, and you can see a nice pixelated UV map. Copy and paste. And for this one, let's get the blue and alpha channels, and this is our size. You can see here over here that this giant quad original space is its side horizontal is 1 and vertically is 0.325, and we can use that information to make a high resolution UV map. So let's first make a normal UV map with a ramp. Maybe you've seen this before. This has to be the same resolution over here, and make this 32-bit mono. And we can copy and paste and make this other one vertical, and then we can use a reorder that gets the green point on the second input, and this is RG. That's a UV map, and we can transform this to be a bunch of tiny UV maps for each of these kind of pixels. So we can use this grid for a scale, and we get the inverse, so 1 divided by, and for the vertical scale we use the vertical grid resolution. And you can see we have now a tiny UV, and the pivot should be 0, so it's on the corner, and now the tile to repeat, and we have a bunch of those, and everything should be in nearest pixels. Look at that. And now we can use that to kind of fill out the information that is missing from this pixelated, from this quantized version of a UV map. Like you can see over here, there's a lot of empty space of like the intermediate values that aren't represented. So let's first scale down these values to be the size corresponding to each pixel. We can do that with a math, and I can actually copy this same expression and use that to multiply by the channel by that amount, so the red channel by the inverse of the grid on X, and the Y channel, let's change that to Y for the green, I mean. And now with this we also have to scale these values for the relative size of each of these segments of space, these quads. So let's do a comp here to divide. It should be put it here, and it should be the other way around. So it's this divided by the size. You can use here divide. And now with this I can add that to my pixelated UV. And now we have a nice and smooth gradient that is a UV map for each one of those segments. That's really nice, and we can of course use that to remap whatever we want. So let's just get a text, but it can be whatever texture we want, and I can banana, and let's make that really big. And also let me vertical align to bounding box, and I can also transform this so it actually fills out the whole thing. This doesn't need to be a square, it can be any texture, any size or anything. And we can put this here. It's the other way. And there we have what we wanted. Now here I want to set the resolution source to be input 2, so our UV map. and that means we're gonna have to change this to be in the format of the texture that we want to work with. And also let's change to nearest pixels. And there we have our thing, and we can select our input to copy it over, so we have our final look from the beginning. Really cool. And you can see the kind of precision of this collision shape and how these shapes around the silhouette is gonna depend on the resolution of your grid. So because we're doing first horizontal and then vertical, it's way better to increase on the x-axis the resolution, because if you increase on the y, you're gonna end up with really thin slices, which you may not like. And for example, if right now I turn this to a really low value on the x, it gets to be not as good to getting a nice silhouette around it, and you can see some of it even jumps into the banana. I can see this weird thing is going on over here. I guess it's from the adding, but well, you can also select this mask and fit it and multiply it back. Let me show you. You can select this mask. You can even copy this fit. And let me just invert that like this, 1 to 0. And you can, after you remap, you multiply, so that you make sure that the space inside of your silhouette is empty. So that's nice. But as I was saying, it makes it less precise if you lower this too much. So you should keep that relatively high, but of course that means it becomes a little bit more expensive to compute. And also you can add a little bit of room around your silhouette just by blurring whatever you're using as your input. So I can just blur that, because we're using the alpha for our threshold. Let me blur it a bunch, and we can when I decrease this threshold, you can see the shape expands, and now we get a nice contour, a nice margin around our shape. I think it looks really cool. Another thing is that if you wanted to make this so that there's different textures in different quads or in different parts, you can use this size information as a seed for a noise. So you can put this into our second input. Let me just change this to output only the noise and the pixel format to 8-bit. And you can see now there's a different noise generated based on the size of each quad. That gives you most of the time a different noise for each different quad, and then you can use this to maybe mask different quads to have different textures, or maybe change the color, or all of that stuff. I think it is really cool. This was really fun to figure out. I hope you enjoyed it. I hope you found it interesting. I'm gonna have, as always, this project file on Patreon if you want it. Thank you a lot for watching. Goodbye.